Hello everyone. Welcome to the second session, I guess, of the UPAC Colloquium, the Utrecht Philosophy, Astronomy and Cosmology Colloquium, organized by the UPAC group. Many of us are here. Sana, Antonio, Antonios, Alex, Elizabeth. Maybe the others are online. Yeah, I think Sabine is online, maybe Koen. That's us. As you're aware, the colloquium takes place every Tuesday. It's Tuesday now, unless there's a Descartes colloquium, which is the local in-person colloquium here in History and Philosophy of Science, typically the third Tuesday. Or if there's a fifth Tuesday of the month, then we all have a break. So basically, this means the first, second, and fourth Tuesday of every month we have a UPAC colloquium. Typically, the first week of the month we have a speaker. The second week of the month, a reading group session where we all read something beforehand and discuss it. And this month we swap those because a speaker lost his voice, but now has his voice back. Yes. And then the fourth week of the month, typically we have a work in progress session where someone sends us a draft beforehand and we discuss that. It always ends at 5, but the speaker session is 1.5 hours. The other session is 1 hour, so that means today we start at 3:30. Other days we start at 4. Lots of info. You can get it all. It's on the website. But now you've at least heard it once. Okay. That was all about the colloquium. So we can move on to our inaugural speaker, Simon Allzén, who is a philosopher of science, philosopher of physics, philosopher from lots of things at the University of Stockholm. But there he got a Swedish rank to actually visit the University of Amsterdam for a few years.
Yeah, right. 3 years.
3 years, so we're very glad to have you around the corner. And Simon is going to talk to us about a topic that's very dear to my own heart, whether it exists or doesn't, doesn't matter. We're recording this session. It will probably go on YouTube. So if you don't want to be on YouTube, you may turn off your webcam. After the talk, we'll stop the recording, have a short break, do a Q&A without recording, so then you can ask whatever you want to ask. So now, without further ado, Simon, take it away.
Thank you. Thanks for coming. Thanks to the UPAC group for arranging this. It's a bit of a mix, this paper. So it's partly sort of history of science, which is relatively new to me, and philosophy of science, which is sort of my main field. So this is like current work in progress. I know I should have probably had a work in progress seminar, but I didn't get invited to do that, so now I'm doing it here. So please feel free to sort of come with suggestions in the Q&A, or just push me on certain aspects of this. Okay. So the general outline of this talk is going to be aim and motivation. So why am I trying to do this project at all? And what do I think can be a fruitful result of doing it? So I'm going to talk a bit about sort of epistemic, the sort of lack of empirical data in physical theories that's in the sort of frontier of their field, and what they can do to sort of get additional support when there's no way to empirically settle it in the sort of canonical way. And then I'm going to talk about Whig history, which is a historiographical term, which is also new to me. I don't know if it's new to you, but I'm going to spend a little bit of time on that. And then look into how Whig history is being used in the context of dark matter hypothesis, and then do a little bit of a case study to sort of hammer this point home. So, motivation. So this is my sort of ambitious aim. Let's say sort of the grander, maybe lofty, maybe unrealistic, but to gauge the significance and function of using history as epistemic support were theories in physics, which are not canonically confirmed. And the less ambitious aim is to do the same, but just with respect to the dark matter hypothesis. So this is sort of a preamble or motivation, which if you have any suggestions on sort of carving this out more neatly, I'll be very, I'll appreciate it. So it seems to me that in 20th century sort of science in general, and physics in particular, particle physics has been a standout case in terms of empirical success. The sort of discovery and categorization of all the elementary particles via collider experiments has been unmatched, pretty much. And I think, this is conjecture, but I think because of this success, people started to view this sort of methodology of, theoretically creating a model and then predict and then discover via sort of manipulating the constituents of the world. They viewed that sort of methodological package as being sort of a representative of the scientific method. So if you compare, for example, the epistemic status of particle physics sort of during the 20th century with the relevant comparison would be in cosmology and astronomy, where cosmology was this fringe speculative science for a much, like a big portion of the 20th century. Astronomy had better standing, but it was still far from the sort of gold standard epistemology that particle physics enjoyed. And I want to sort of focus on when particle physics became involved with cosmology and astronomy in the sort of late 80s, because they became interested in this missing mass problem. So I'm going to sort of talk about two things that I think happened when particle physics intersected with cosmology and astronomy. And the first thing I think was that there was an ontological shift. So the missing mass was hypothesized to be an unknown subatomic particle, as opposed to some astronomical or astrophysical entity in like white dwarfs or gas or whatever. And I think there's a peripheral sort of remark on the possibility of neutrinos having an impact on the evolution of the universe, or the sort of natural particle candidates that was coming from supersymmetry. But I think this still happened, this shift. And I think the shift was necessary in order to sort of access this incredibly successful methodology. So this sort of brings about the second point here of epistemic optimism. So it seems like particle physics came and was like, they were thinking, oh, maybe it's a particle, and we're really good with finding these particles in our detectors. Which also means that your theories about dark matter or missing mass can be confirmed in this like really bona fide way. So I think looking at some people who were optimistic about this idea, sort of the epistemic optimism shines through. So Frank Carlos, is a cosmologist, is willing to bet that scientists will identify dark matter within 5 years. So this is prior to or simultaneous with a big symposium at the time. And Dan Hooper from Fermilab says, in fact, I made a bet in 2005 that dark matter particles would be discovered within a decade. So it seems like this optimism can be clearly seen by the likes of Hooper and Carls. And so with this in mind, I think I can sort of extract a couple of consequences, a couple of things that led dark matter research to the sort of situation it is in today. And accepting these two sort of aspects, and I think, so this is like also periphery thing, but especially the sort of sigma standard that is prevalent in particle physics makes the evidence that was already in place before the ontological shift undermined, epistemically speaking. So if we're sort of saying yes, we would like a detection experiment that's clearly the better epistemology, then you're saying, well, that means that all the evidence we had before isn't of that kind, doesn't weigh as much. And I think also accepting these two aspects lead to the undermining of future evidence of the sort of non-detection sort as well. So if you've said, if you've accepted the primacy of detection via manipulating constituent bits of matter in a particle detector or accelerator, you can't really take that back. So you accept it, you have the wind paradigm, you say, well, this is done and dusted. Within 10 years, we're going to have found dark matter. Then it turns out you didn't. You can't really say, oh, well, I never really believed in that methodology anyway. So I think it's like a principle stand. Like there is clear evidence that people accepted this, and I think they can't really retract it now that it's not bearing fruit. And this has been sort of interesting. So for me, a little bit of background. My thesis supervisor was Richard David in Stockholm. So he's the kind of go-to guy for sort of non-empirical confirmation of theories. So naturally, I've been interested in that as well, but maybe coming from a slightly different angle. So I'm trying to look at different aspects in which people have argued for believing in a certain theory for reasons that aren't to do with like detecting or experimenting. So I think if you're dark matter scientist and you're looking for sort of alternative routes to support your hypothesis, you might use this multidisciplinary consilience, as the internet told me it's called. So I think philosophy and history are two candidates that have been employed in order to do this work, and so I'm going to focus on those, or today I'm going to focus on history. But just a disclaimer here that this isn't to say that there aren't really good reasons to think that a particle detection then would be the gold standard. I'm not saying that you should look to sort of philosophy and history for the sort of same amount of support. I'm not saying that at all. I'm just saying there are reasons to think that such counts have been used in order to give support. So in philosophy, I think, or sort of subject of philosophy has been used as a way to strengthen the already known evidence, because you can sort of make clear exactly what kind of inferences you're using. You can make arguments to support using those inferences, the legitimacy or justification of using these inferences. And I think that's an interesting route. I think that's one route people tend to take, whether or not they actually think they are taking that route. But still, I think if you would look at philosophy for those kind of arguments, they're there, right? We've been talking about those kind of arguments for a long time. And I think I've talked about this, and I think Niels talked about this as well, in your paper on dark matter realism, somewhat. So I'm not going to talk about the strategies, just one or two, but they're sort of interconnected in terms of the logic. So I wanted to see whether or not people have been using history for the same reasons. So I think history can be used to support the scientific pedigree or merit of a theory, which sort of lacks these sort of canonical forms of confirmation. And I think they are often used in a variety of different ways, but sort of if I can, in the larger sort of project that I'm working on, if I can sort of showcase these three, I might be on to the sort of ambitious aim at the beginning. But I'm happy with just maybe demonstrating the last one. We'll see. So I think the first kind of historical argument that people make is to connect your theory that you're looking to support with some scientist of high merit or high standing. So Brian Greene in this quote is arguing for sort of taking string theory to be a viable theory because of its connection with Einstein doing unified field theory. So this is Greene then. For 3 decades, Einstein sought a unified theory of physics, one that would interweave all of nature's forces and material constituents within a single theoretical tapestry. He failed. Now, at the dawn of the new millennium, proponents of string theory claim that the threads of this elusive unified tapestry finally have been revealed. So this sort of argument sort of says, well, the history of string theory goes back farther than you might expect. Actually, Einstein was doing string theory in a way. So he's trying to sort of boost the confidence or the support for doing string theory by connecting it to the aim of Einstein's unified field theory, which is kind of ironic because that's the part of Einstein's legacy that people are reluctant to think is worthwhile. But anyway, the argument's there. The second historical argument is to connect the scientific theory to a theoretical virtue. So there are a couple of theoretical virtues in the literature. I think in physics, unification is by far the most common one. So the underlying claim here is that, well, if you can't, so unification and sort of scientific viability, let's say, they always come together, they're coincidental. So if you can have viability on the basis of some empirical experiment, you can just look for the science of unification, because since they're coincident, so you have the one, you have the other. I think that's the underlying claim in this argument anyway. So here's Leon Lederman, I think, exemplifying this approach on this sort of T-shirt moniker. My ambition is to live to see all of physics reduced to a formula so elegant and simple that it would fit easily on the front of a T-shirt. So having this virtuous property of unification is a telltale sign that your theory is viable, therefore it offers epistemic support in some degree. And so this is the last one that I am going to sort of zoom in on today. I call it linear progress. I'm not sure about how to exactly frame this in the right way. But the idea is that you show that a theory's scientific viability is larger by understanding its history, its accumulative and linear theoretical empirical progress. So you're showing, oh, this was always a good theory with well-defined boundaries, that, you know, we have this idea about the existence of something, and then we come to learn more and more about that something. There's a kind of stability of reference, there's a stability in phenomena and ontology. And I want to suggest that this is one argument that is frequent in the dark matter case. And I will also argue that it reduces to Whig history. So thereby undermining the epistemic value that any such argument has. So Whig history is like the most recent term that I learned while doing this, because I already had the idea, and I talked to it with Jeroen van Dongen in Amsterdam. He said, "Oh, it's Whig history." I said, "What? I mean, I don't know about that." But that's apparently what it's called. It has historical reasons for being called that, having to do with the Whig Party, I think, in the UK. Yeah, people are nodding like, "Why didn't you know that?" So for those who aren't already familiar with the term, I think this is a nice sort of definition or outline of what it is from John Schuster. Whig history is the evaluation and explanation of history from the standpoint of assigning merit and demerit based on some values and ideas accepted in the present. So the idea is that you make certain decisions about what to include in a history, what to not include, who was insightful, who wasn't. All these kinds of decisions when you're writing history can be influenced from your sort of modern day perspective. And this is a bad thing because letting the influence of contemporary ideas about what's true or what's valuable impact the history, you're misrepresenting it, but you might also it's not just for bookkeeping purposes, right? It's having to do with emphasizing the role of certain theories, for example, today. Oh yeah, so Whig history doesn't have to be the history of science, obviously, but I think it's a very good case for it. So this is Schuster again, talking about Whig history in the history of science. Most history of science are Whiggish histories of science. They judge the past by standards of what currently is accepted as true and good in science. And just to exemplify, Steven Weinberg, in his book To Explain the World, The Discovery of Modern Science, actually sort of admits to this, taking this perspective or doing Whig history. And he argues that it's perfectly fine to do so, because the history of science is not merely a tale of intellectual fashions succeeding one another without direction, but a history of progress towards truth. So if that's true, we have more sort of truth now than we did back then, which means that we can judge their sort of rational calls or decisions by some more objective measure, I think is the idea. Don't think that's a good strategy, but he does it anyway. So Here's then some examples that I picked from the history of dark matter accounts that I think can sort of tell you a little bit about how Whig history sort of sneaks up on you when doing these accounts. So here's Sidney Vandenberg, I don't know, I'm sorry, in a paper called The Early History of Dark Matter, published in the Astronomical Society of the Pacific. And he says, the discovery by Zwicky that visible matter accounts for only a tiny fraction of all the mass in the universe may turn out to have been one of the most profound new insights produced by scientific exploration during the 20th century. So this is quite a statement, right? It says that there's been a discovery made, which already presumes that there is something there to be discovered, right? And also, the role here that he assigns to Zwicky, or this sort of stature, the esteem that this bestows on Zwicky in this sentence is quite striking. And the second picture here is from Schuster as well, sort of a visual thing of how this goes. So you have some idea about present scientific truths, and then you make a judgment about the historical figures being sort of good guys, like Zwicky, having those amazing, most incredible insights, or bad guys. So people who didn't believe Zwicky. And here's another case. So this is Robert Sanders in a book, The Dark Matter Problem, A Historical Perspective. Unquestionably, Fritz Zwicky was the first to propose this form of dark matter, although for 30 years after his proposal, it was largely unappreciated. So this is the bad guys, right? They don't appreciate these great insights of Zwicky. Astronomers did not see Zwicky's anomaly as a crisis leading to a possible paradigm shift. It took about 40 years for Zwicky's insight to be fully accepted. So I think this touches again on the idea of who's insightful and who's ignorant. And I think this judgment is clearly made from a contemporary perspective. So these are further examples just to sort of hammer home the point. Fritz Zwicky's pioneer, that was questioned until 1970s, when apparently there is confirmation of dark matter, which is interesting. Choice of wording. And then this is Sanders again, the whole last quote. Rare, unorthodox genius, decades ahead of his time. He got grumpy because no one believed him. So all this is like, I think, just shows you how the contemporary perspective when writing these histories has been allowed to take place and make these judgments. So that was just like in general to try to show you that there are these tendencies in writing the history of dark matter, or a history of dark matter, from a few different places. But for like a real, I guess, more detailed, thorough case study, I wanted to have a case where physicists write history about dark matter, which is published in physics journals intended for other physicists. Because I think that those kinds of texts have a higher likelihood to be of a sort of argumentative kind, or in a way that, you know, offers justification or support to a theory. And I'm not in it to slap anyone on the wrist. I'm not in it for bookkeeping purposes. Like, this goes back to my interest in just like the weird situation of physics just having outrun technological progress, basically. There is this sort of barren empirical landscape lying ahead, painting a very gloomy picture, but I think there's evidence to support the idea that people have started to sort of look elsewhere, like, are there certain argumentative strategies? Can we establish support via some participation in unification or other virtues? Like, I'm interested in what people do in this sort of situation. So, from my perspective, I think the account of a history of dark matter that I would go to for this case study is Gianfranco Bertone, who sits in the hallway where I'm sitting. So we're gonna have a talk. We'll see how that goes. He wrote a paper with Dan Hooper that's called A History of Dark Matter. So already there, you see that it's not the history of dark matter, it's a history of dark matter, which suggests that a certain modesty, which I like. So it's a very thorough, so it's wide scope, but it's very thorough and detailed. It's published in Reviews in Modern Physics in 2008, and this is the aim of the paper, as stated by them. The aim of this review is to provide the reader with a broader historical perspective on the observational discoveries and the theoretical arguments that led the scientific community to adopt dark matter as an essential part of the standard cosmological model. So I think already, in my mind, you're mapping out the bits that actually convince people. So I think the aim sort of sets you up for this like linear history Whiggishness, because you're going to focus on the stuff that made people believe in dark matter. And it's a publication, yeah, 2018. It's been cited at least 939 times. So it's a kind of a popular paper, which kind of also tells you that there is interest in history within the community. So just looking at the table of content, not the whole thing, but just the early history, which I'm interested in today. You can sort of see how this converges to a certain point, right? So it's purely wide scope of prehistory, which has three sections. I will be most interested in section C. But it's interesting to see, yeah, they have found source material that they think is relevant, and then they've chosen to categorize it as prehistory or not prehistory, like actual history of dark matter is the assumption. So in this prehistory, in the subsection dynamical evidence, we have source material from Lord Kelvin, Poincaré, Öpik, Captain, also a Dutch name I'll probably butcher as well, James Jeans, Baptiste Lindblad, Swedish name, I know how to pronounce that, and Jan Oort. So these are the kind of main figures of that section. And all the sources cited actually explicitly refers to dark matter, or use the term dark matter explicitly. or are such that they offer explanations of the dynamical phenomena that we today associate still with the presence of dark matter, or both. So I think it's my sort of hunch, let's say, that selecting specific sources like that, like those selected, and classifying them as prehistoric, has a dual function. So it amplifies the sort of thematic linear progress because it's still relevant, right? It's still there. It's just in the prehistory section, but you can sort of see that already at that time, people were starting to talk about this stuff. But by classifying it as prehistory instead of the actual history, also makes you justified in saying, well, they thought it was this and that and such, and clearly, well, that's wrong. But since it's prehistory, I don't have to accept the sort of ontological or semantical content in my sort of idea of the evolution of dark matter as a theoretical notion. So it's a way of sort of compromising, I think. You want to say, oh, look, there's been people talking about this stuff for a long time. But you also want to say, well, that stuff that they were talking about isn't quite the stuff that we're talking about. So it's this compromise, I think, between two functions. And so here's why I think that this dual function doesn't really work. So there are some included sources, obviously. But so if excluded sources that are contemporary with the included ones also use the term dark matter, but in explanations of phenomena that we today know are unrelated to dark matter phenomena, the case for thematic progress would obviously weaken. And I think it would provide stronger indication or a better indication of how using the term dark matter in that time, what people meant when they used the term, right? So I think it's easy to sort of say, well, in their history, we only included the ones that were kind of on the right track. We didn't include the ones that were way off, right? And that makes it look sort of nice. But I don't think that history lends itself for that kind of nice progress. So I think one upshot of this argument is that if if I can show that the use and perception of dark matter can be shown to include more sort of theoretical content than in the included parts, and that the way to use that term continues well beyond the sort of point of the point in history when sort of real dark matter history starts, which is usually by Zwicky. People want to include Zwicky as a sort of, well, he obviously wasn't the first, as Sanders said, but they still want to place some sort of emphasis on Zwicky's role here. So that would be early 30s. But if the notion has more theoretical content than sort of desirable and also goes way beyond that point, you can sort of say, well, then, prehistory is all the way up to the 50s. So why prehistory? Why does prehistory end where Zwicky begins, right? And in some sense, the selection is an argument or a way to show that whatever was before Zwicky was like hand-wavy, sort of speculative. So that's why it's prehistory. But I think it can be shown that the concept of the prehistoric times went on way past Zwicky. So yeah, rhetorically, are there such sources? Yes, there are. So this is an image of this Sagittarius cloud, the Milky Way, taken by Barnard in 1919, and it's supposed to be a hole in the middle. I don't know if you can see that, but there's like clear absence of starlight. And so people started coming up with these explanations for why don't we see any stars in certain regions? And most of these explanations feature dark matter as an explanation. So this is de Sitter. Gradually, evidence has accumulated to convince us that there are not places where there are no stars, but where there is something to prevent us from seeing stars. Clouds of dark matter, either in gaseous form or more probably in the form of finely divided dust. So clearly invoking here dark matter to explain why we don't see stars there, because the dark matter is blocking the light. And Trumpler has a similar explanation. Not only do we find dark matter of wide distribution in our own galaxy, its presence is even noticeable in many of those other distant stellar universes, which we call spiral nebulae. And because I'm currently at the Anton Pannekoek Institute, I had to include him, and I think it's for good reasons. We come to the conclusion that visible stars of the galactic system cannot provide the required central attracting masses. Cannot the dark matter itself act as a part of the attracting masses? In the visual aspect of the Milky Way, that dark absorbing nebulae have the same importance as the luminous star clouds. So Pannekoek connecting sort of explanation of light blocking phenomena and explanation of dynamic phenomena sort of attributes them to the same thing, namely dark matter. So I think I can make the case that the term dark matter was frequently used to explain phenomena having to do with blocking light or obscuring light. And in Pannekoek, I think there's also evidence to show that there wasn't like another sense of the word in which they used to refer to like blocking stuff, and one that was used to have for these like dynamical explanations of dynamics, like galaxy cluster dynamics. These are the same, right? So that's important. And I think there's also a quote by Oort. So they all read each other, right? So they read each other's stuff, and they're like, yeah, the dark matter is blocking the light in the Sagittarius. That might be responsible for this gravitational phenomenon. And then if you only pick papers when you write the history that talks about the gravitational phenomena, it's going to look better, right? Because that's the stuff that we today associate with dark matter. We don't want the other stuff, because that would mean it's blocking light. So dark matter really is interacting electromagnetically. No, it's not. And I think also Oort uses dark matter as in the sense of blocking light already up to 1952. So there's really no nothing to sort of say, oh, well, that's a prehistoric concept. You know, past Wiki, we got rid of that. No, well into the 20 years somehow. I think, yeah, 20 years after Zwicky's first paper. So this is like a concluding remark. Separating the parts of history that from our perspective was on track, or at least still compatible with current theoretical ideas of dark matter, from those that were not. I think that's fairly Whiggish. And I think that sort of undermines whatever epistemic support that one thought that such an argument had. And I think it leads to a number of interesting related research questions. So if there's a history of dark matter at all, it must mean that the sort of the ontological commitments of the past and the present, like, can they be directly contradicting each other, or does it have to be some overlap? So is there like one theoretical sort of path from the past to the future, or is this like the ship of Theseus, where, you know, all the parts have been replaced basically now? Yeah, and how much of the concepts or the properties theorized have to be the same in order for us to be talking about the same thing? Yeah, at some point, I think, it becomes an equivocation to say that the dark matter of today is the dark matter of the past. Okay, thanks.